All right, so we're going to move away from the circuits for a little bit, and we're going to talk about something called the discriminant. To do that, we're going to visit our old friend, the quadratic formula. So let's see if we can remember how this works. We have x equals negative b plus or minus the square root of b squared minus 4ac, and all of that together is divided by 2 times a. So there's the quadratic formula. Now you have to know what a, b, and c are. You find them in a polynomial formula. A is in front of x squared, b is in front of x, and c is the constant all by himself. And they have to have a 0 on the other side of the equation. The 0 is important. If you don't have the 0, you can't do it. So we're going to run 3 equations. There they are. And notice that all 3 of them are pretty much the same except for the c part, or the constant. So in this first equation, a is going to be 1. That's the hidden number in front of x squared. b 6, c is 5. We're going to plug them into the formula. And we'll find out what x equals. So we want negative b, or the opposite of b. b is 6, so we'll put in a negative 6. Then we'll take that same b and square him in the radical. Minus 4 times a, which is 1, and c, which is 5. And then all over 2 times 1, because that's 2 times a. a is 1. Now the 6 squared is 36 minus 20. 36 minus 20 is going to give us 16 under the radical. And 2 times 1 on the bottom, that brings us back to a 2 on the bottom. Now 16's got a square root. We actually know what that is. So that gives us a negative 6 plus or minus 4 all over 2, because we actually know what the square root of 16 is. And now we're going to split the problem into 2 pieces. We're going to split it where the top is adding, and we're going to split it where the top is subtracting. And then we're going to figure out what those are. Notice we haven't used the bottom yet. That 2 is still sitting there waiting until we're completely done with the top. And once we're done with the top, our final answer is negative 1 and negative 5. Next problem. Again, the only difference in this problem is the c. A is still 1, b is still 6, but the c is now a 9, and we've got a 0, so we can proceed. It's always important to have a 0. So again, we have negative 6 on the outside, just like last time. And then we have 6 squared minus 4 times 1 times 9. That 9 is the only part that's different. We're going to see what happens to this. So we have 36 minus 4 times 1 times 9. That's 36 minus 36, which gets us a 0, which is kind of a funny number to have under a radical, but yeah, there it is. All right, now 0 happens to have a square root, kind of. It's 0. So now we're going to split the problem. Again, we're going to have a negative 6 plus 0, still over the 2, and a negative 6 minus 0, still over the 2. Negative 6 plus nothing still happens to be negative 6. So we end up with negative 6 over 2. And negative 6 take away nothing is still negative 6. So we end up with 2 fractions that are the same, and when we simplify it, we get a single answer. It's just negative 3. All right, time for the last problem. All right, we've got the 1, the 6, and c is a 25. And again, the c is the only thing that keeps changing. So the rest of this is going to look very similar. Negative 6 again, plus or minus. There's that 6 squared. Minus 4 times 1 times 25. The 1 is the a, the 25 is the c. All over 2 times 1, 2 times A. We have 36 minus 100 this time. 4 times 1 times 25 is 100. So that gives us, under the radical, a negative 64. That's 36 minus 100. Now this causes some issues, because a negative under a radical, that's the I. And then 64 has a square root, it's 8, but it's attached to an I because it was negative under the radical. So it wouldn't help to split this into plus and minus fractions like we did the others, because we can't combine the top. We can reduce it. So since they're both being divided by 2, we can divide them into negative 3 and 4. We can't really do anything more than that. And that's a 4i. So the I is still attached. So the only thing different as these problems progressed was what ended up under the radical. The rest of it on the outside, negative 6 and 2, remained the same. The radical is what's making different kinds of answers. That's the discriminant. So the discriminant is the part under the radical, and what the discriminant does is it discriminates or chooses the kinds of answers that you're going to get. So the discriminant is b squared minus 4ac. That's just the part under the radical. And it tells you whether or not you're going to get real answers, one answer, or imaginary answers. So here's how the breakdown goes. First problem, if the discriminant is bigger than 0, underneath the radical, we had a 16. It's bigger than 0. You're going to get 2 real answers. They could be numbers, they could be negative, they could be decimals, but they're real. If your discriminant equals 0, like it did in the second problem, there will be 1 real answer. Could be negative, decimal, positive, but it's a real answer, but there's only 1 of them. Finally, if your discriminant is smaller than 0, then you're going to get 2 imaginary answers. And there's 2 of them because there is a version where they add and there's a version where they subtract. Now, another way of thinking about this is if your discriminant is positive and then 0, or if your discriminant is negative, which would be the less than 0. So you can also think of it like that. Positive is 2 real answers. 0 is 1 real answer. And negative, a negative discriminant, that's just what's under the radical, creates 2 imaginary answers. Okay, now that we know what the discriminant is, we're going to work on basics. How do we find it? This is one of the first things you do in your worksheet. So first of all, let's recopy that discriminant. It's b squared minus 4ac. And you need a 0. Make sure you've got a 0. And then things are a, b, and c in order. A is on the squared, b is on the linear, c is the constant. So we're going to fill that in. We have a negative 6. Put the negative and the 6 in the parentheses. Square needs to be on the outside of the parentheses. Otherwise, if you do a calculator, it won't work. Okay, a is 3, so we're going to fill it in behind that 4. C is also 3, so we're also going to put that there. And then we're just going to find out, what do we get? Now, this is the thing that would normally be under a radical, but we just want to know what it is, because this is what chooses our answers. So 36 minus 4 times 3 times 3, another 36, 0. The discriminant is 0, and we're done. That's the first part of your worksheet. Just find it. Next part of your worksheet is going to say find it, and then tell what it means. Are there 2 real answers, 1 real answer, or 2 imaginary answers? But first of all, we've got a problem. Something is wrong with this equation. There's no 0. We're going to have to make a 0. So to do that, we're going to clear off one of the sides. We're going to add an 8 to clear out one of the sides. So we're clearing off the right side. But unfortunately, that means negative 8 plus 8, we get another 0. But I'm going to keep it because we actually need that as a placeholder for the C part. So we could cancel it, but we need it. So here's the discriminant again, b squared minus 4ac. And I'm going to put little labels A, B, and C. So b is again a negative. It's a negative 2. So we have negative 2 in the parentheses. Squared is on the outside. And then 4 times 2 times 0. All right, and negative 2 squared is 4, and then 4 times 2 times 0 is still 0. And 4 minus 0 is 4. Okay, so that's positive. So we know the discriminant is 4, and we know it's a positive discriminant. It's bigger than 0. And a positive discriminant is 2 real answers. Because positive numbers, those are the normal numbers we work with, so they should give us normal answers. So there are 2 real answers because our discriminant is positive. We don't know what those answers are, but we know there's 2 of them, and we know they are real. All right, last but not least, we're going to solve some problems, a lot like we did right at the very beginning. And in order to do this, we need our quadratic formula again. So the discriminant is what's under the radical, and it will help us predict partway through what kind of answer we should have. So first of all, make sure we have a 0, which we do. So I'm going to label A, B, and C. Now we're going to plug it in. So quadratic formula, we want negative B. So that's going to be a negative 20 plus or minus. And we're going to take that 20 and square it. Minus 4 times A, which is 10, times C, which is 34. And all of this is over 2 times A, which is another 10. All right, so 20 squared happens to be 400. So we've got 400 there, and then 4 times 10 times 34 happens to be 1360. So again, simplify under the radical first. And we've got 400 minus 1360. That's going to give us a negative 960 underneath the radical. And then 2 times 10 on the bottom gets us 20. Now, negative 960, there's that negative. Okay, make sure you track the negative. And then 960 can break apart into 64 times 15. And that's important because 64 happens to have a square root. So we've got our 64, 15, that's 5 and 3, no square roots there. So we're going to simplify this a little bit. So we have negative 20 plus or minus. That negative is an I. The 64 will get out as the number 8 with its square root. And 15 will stay under the radical. And then see that negative under the radical, back a little bit, the discriminant predicted that we would have I in our answer, and we do. We have I as an answer. Now, we can't combine the top. They're not like terms. But what we can do is we can look at all 3 of the normal numbers that aren't in radicals, 20, 20, and 8, and they can all be divided by a 4. So we could reduce the fraction by 4, and that will get us negative 5 plus or minus 2i, radical 15, all over 5. The radical does not participate in the reduction. Only the real number, the normal guy in front of I, and the denominator are reduced. Radical 15 is still radical 15. All right, this problem, last one, has a problem, has an issue, doesn't have a 0. So we have to clear off one of the sides. I'm going to clear the right side. I'm going to move the paper up a little bit because the red looks awfully faint. So we get n squared minus 4n minus 60 equals 0. There it is. We have our 0. Life is good. So I'm going to again label A, B, and C. There's a hidden 1 in front of n squared. That turns into our A. And here comes full quadratic formula. Now, since B is already a -4, it will go in as a +4 in the very front. And then plus or minus B squared, so -4, and the square is outside the parentheses. So the answer to that squared part should be a +16, because we should square the negative and the 4. And then we're going to have -4 times 1 times a -60. That negative is important on the 60, on the C part, so make sure you do not lose that. Okay, and then that will all be over 2 times A. And A, again, in this case, is the 1. So it's all over 2 times 1. And I'm going to reevaluate this red pen. We're going to switch to a black pen because this is just not working. I thought it would, and it's not. So anyway, we're going to create 4 plus or minus. Now, under the radical, we have 16 from our -4 squared plus 240. That's 4 times 1 times -60. And the reason it's plus is the negative in front of the 4 and the negative in front of the 60 canceled. So 16 plus 240 is 256, and that's got a square root. Now, some of you keep writing the square root, so make sure you don't, okay? So if you're tempted to keep writing the square root, don't. Once you take the square root, there's no more square root. So now we have 2 problems. We're going to have 4 plus the 16 that came out of the square root, and 4 minus the 16 from the square root. So 4 plus 16, we get 20 over 2. 4 minus 16, -12 over 2. And we can reduce those fractions to 10 and -6, 2 real answers. And if you look at the discriminant under the radical, it was positive. It was 256, 2 real answers. The other problem had an I in it, and its discriminant was negative, so it predicted 2 imaginary answers. So partway through the problem, we knew what kind of answer we should expect to have.